Hi, and welcome everyone. So today's webinar is From Forest to Frame, using Georgia's forests in local mass timber buildings. And we have panelists Troy Harris and Russell Gentry with us. And I'm also delighted to welcome Lynn Wilson, who's actually going to be serving as our guest host for this webinar. Lynn has a long and distinguished career in the forest products industry. She was the vice president of supply chain for Louisiana Pacific before becoming the president of Wintertide, LLC. She currently serves on the board of directors of Roseburg Forest Products, and she was also a longtime member and a chair of the Forest History Society Board of Directors. And I should mention she is also a fellow of the Forest History Society, which is the highest honor that the FHS bestows on our friends. So Lynn, it's very good to see you. Thank you so much. And I will hand it over to you.
Thank you so much, Tanya. And I really appreciate this opportunity. I'd like to welcome everybody to the Forest History Society's inaugural Forest Optimism webinar series. As Tanya said, I'm your guest host from Forest to Frame, using Georgia's forest and local mass timber buildings with Troy Harris and Russell Gentry. Russell Gentry is a professor of architecture and associate dean for the faculty in College of Design at Georgia Tech. He's a licensed structural engineer and building materials researcher. His research focuses on technical performance aspects of building materials and their components and assemblies. His work considers mature building material and systems with ongoing projects in wood and wood composites, and on emerging building materials with work in FRP, fiber reinforced polymers, and bio-based residues. We also have Troy Harris, who is the managing director of Timberland and Innovative Wood Products at Jamestown, with 30 years of experience in timberland portfolio management. Troy is a passionate advocate of the mass timber industry and has been vital in connecting it to the commercial real estate industry through his work to build 619 Ponce in Atlanta, the first Georgia-grown mass timber building. I'm really excited to be your guest host for this webinar series. We're spotlighting what is working in forestry and related fields and conservation. What's special about this series is we all know, as Tanya said, how forests are in the news, whether it's wildfires to habitat, species loss to illegal logging. It seems that we hear many alarming things about our forests. And while concerns about our forests are valid, emphasis on the negative to the exclusion of other news can be overwhelming and overshadowing all that is working in how we manage and conserve our forests. Healthy forests and sustainable forest management are the solutions to many of today's challenges. The Forest Optimism webinar series is a way to tell those stories of what is working across the spectrum of forestry, related research, industry, land management, and conservation efforts. I'd also like to share from my years with the Forest History Society that this Optimism webinar is aligned with the mission and vision of the Forest History Society and our strategic plans objectives of increasing the visibility and awareness of forest and conservation history for a diverse range of local, national, and international audiences. Today, we're going to explore with Russell and Troy how substituting mass timber for traditional building materials has the potential to reduce the carbon footprint and incorporate the beauty of wood into architecture. This event will last around 75 minutes, and our presenters will speak for about 20 to 30 minutes. We'll hear again briefly from Laura, and then we're going to take questions. So please drop your questions into the Q&A form, not the chat form. You're welcome to submit a question at any time during the webinar, and we'll get to as many as we can at the conclusion of the talk. This webinar is eligible for 1 hour of CFE credit from the Society of American Foresters. And if you'd like credit, please send an email to library@foresthistorysociety.org. Please put CFE in the subject line. We will also drop this email into the chat. And now let's begin. I'm going to hand it over to Russell and Troy.
Well, this is Russell. Thank you, Lynn and the Forest History Society, for having me. And I'm a structural engineer and a developer of wood products. So I'm not a historian, but I thought we would get to mass timber with a really brief history lesson. Troy's running the slides, so when you hear me say next, Troy, you can advance the slides. And I'll just say it's clear to all of us that the first humans lived in wood buildings. Next slide. And as civilization advanced, the use of wood buildings and structures became gradually more sophisticated. But the general characteristics of these early buildings is that the wood was minimally processed, right? Had to be processed using human hands. And the nature of the tree and the branches and the trunk kind of demonstrate themselves in these early wood structures. Next slide. From Bronze Age evidence, we know that woodworking tools became widely available in the metallic age. Wedges, froes, axes, and adzes were used to square timbers. And if you see the riving of timber on the left and the use of an adze to square timber on the right, you can think that a highly trained individual might spend a week perhaps squaring and creating a single wood timber, minimally processed out of an entire tree trunk or limb. Next slide, please. So, of course, the resulting buildings were beautiful. The heavy timber frames and pegged joints, right? An all wood structure, laterally stable, but generally the product of a highly educated and technical workforce. Next slide, please. The construction of these structures was also highly kind of choreographed. And you can see here in early writings, there was actually ways of trying to understand how to assemble buildings without the use of what we have today in cranes and machines. So these early heavy timber buildings went together in a very kind of articulate way. Next slide. These buildings were beautiful. They were fire resistant. They were very durable, and we still have many of them today existing. Next slide. The next bit of technology that's important for us is the pit saw. Two humans sawing and making the first sawn timber, much more effective than using axes and adzes. And a two-person team here could produce perhaps 12 boards a day in a pit saw. So again, the level of production is quite modest. Next slide. As early as the 3rd century AD, the up and down saw was powered by water. So the same actually pit saw approach with the saw going up and down, but we had early water power. And you can see the one on the right here is still in use on Mackinac Island. So if you want to see something like that actually working, it's a treat to see it. And but still, levels of production were quite low. Perhaps the team with the water-powered saw could produce maybe 500 boards a day. So next slide. And this kind of sawmilling led to the ubiquitous kind of heavy timber building that was present throughout, let's say, the northeastern United States at the time of the Industrial Revolution. These were heavy timber interior buildings, usually with load-bearing masonry exterior, which led fire protection and a lateral force resisting system to an orthogonal timber frame. Next slide. But the truly kind of American innovation in building production from timber was the balloon frame. So let's say the mid 1800s, starting in Chicago, gateways to the West, these early timber frames were made of light dimension lumber without the use of heavy timber frames. These buildings could be packaged very easily and shipped out to the West in areas of the country where there was no timber resource. So timber became not a local product anymore, but could be shipped. And these frames were very light and easy to construct, democratizing in a way because you didn't need expertise to construct them. Next slide. And throughout the United States, the balloon frame became ubiquitous. So wood frames were built all over the land, and the single family residence became a unique American artifact, right? The American dream is powered by this explosion of dimension lumber. Next slide. And the combination of the lightwood frame and modern sawmilling practices has led, to this explosion in wood resource. And if you think about producing one wood member every 12 days or 500 boards a day, most sawmills now are producing 500 boards every minute, right? So the rate of production in dimension lumber has skyrocketed. Next slide. And if you look at the population of buildings in America, there are about 110 million buildings in America. 103 million of those buildings are single-family wood homes. And of the remaining, about half of those buildings are also wood, multifamily homes generally. And the subject of today's talk, of course, is mass timber. So next slide. So really, this is just a background and leading into Troy's slides, talking about the idea of producing timber and kits for buildings to be constructed rapidly, effectively, and economically on site. And so I think what you'll see from Troy is the start of returning to the forest and talking about going from heavy timber to mass timber. Troy?
Thank you, Russell. I really appreciate that. That was an excellent lineup into where kind of we are today. And today, I'm a forester by background and training, and that's my role at Jamestown, but we're also a commercial real estate company. And I think what's important in the context of this discussion today is that if you think about what Russell was just talking about in the built environment, where we live, where we work, where we play, that accounts for about 40% of the world's global emissions. And out of that 40%, 11% of that is what we build with. And traditional methods like concrete and steel are heavy emitters of carbon. And so I think what gets us really excited about our industry, and the stories lots of us in this audience probably will already know, is, we've got a great story to tell and a great solution to some of the world's problems. And so if we can substitute the way that we build in different environments, then we have an opportunity to make a really big impact on carbon and carbon reduction goals that we're all trying to achieve. Without going too far, I think it's really important to take one step backwards and just realize and remember the importance of, forests and the importance of private working forests, especially within the United States, because as we move forward in this discussion and talk about mass timber, the people I talk to, the architects, the designers, the developers that are building and want to build with mass timber, often stop short when they say or get the question, are we going to, deforest all the rainforests, or are we going to cut out all the old growth timber, or are we going to run out of wood? I get those questions all the time as the forester in the room. And so I think it's really important to remember that, if we look at the United States, that about 70% of the United States are private working forests. And on those forests, we produce most of the wood products that we need already. 90% of those products come from working forests. Those forests are actively growing, being managed and well maintained. Makes them, sequestering about 75% of the gross carbon already. And then if you think about that, then we've also got the carbon being stored out in the forest. That's about 54%, all at the same time. The reality of life being that we only are harvesting about 2% of our forests every year. So we've got a great story to tell, but as I was explaining, we really need to tell it. And I think that's where we kind of tie in this entire supply chain. And what we're working on is the forest part of the story, all the benefits that come along with that as a carbon solution. I'm tying it to our lumber business and then bringing it forward into our mass timber business, where we're ultimately building a large building that's becoming a carbon vault. And developers, designers are really excited about that. Again, I don't think this audience in general has any misconceptions about what's going on, but as we did our building, we knew that we needed to tell our story if we were going to have this tie back and make people feel good about the buildings that we're doing and the way that we're changing it. And so with some grant monies with U.S. Forest Service and the Georgia Forestry Foundation, we've produced a whole-blown documentary with videos and content explaining how we went from the trees and the seedlings all the way up to a mass timber building in Atlanta that we're going to talk about today. But to do that, you got to start with forests and talk about the young trees and how they grow and how we get everything started. But let's not forget, which is really another important part, we can talk about carbon all day, but our forests are huge mosaics of all kinds of different attributes and benefits to not just carbon, but water. So we take the viewer down to our forests on the Chattahoochee River and talk about water being a filtration, part of the equation and stopping on floods. We talk about biodiversity and habitat and all the things that our forests provide. Along the way, these are kind of who are the people in your neighborhood, if you will, type discussions. But along the way, and as we did our project, we meet people like Larry Grace. Larry Grace works for Forest Resource Consultants and has just recently retired. But as we were harvesting the timber off of the property that we manage, somebody said, you know what? I think Larry Grace managed this forest. And we were able to get to Larry and say, yeah, I remember planting those trees 26 years ago. And so we get to have a forester who gets to tell his story and his experiences on what forestry is and how it's changed since 1996, with the start being the Olympics in Atlanta. Part of our story is harvesting. And so you've got to explain to people what modern day harvesting and it looks like and how that works. So we make sure that we do that. But again, along the way, great partnerships and relationships in this industry. We work with Evergreen Timber all the time with Miss Kim Whittall. Miss Kim is one of the only female loggers that I work with on a regular basis. Miss Kim has, multi-million investments in logging equipment. And so, we get her perspective and a different perspective on what it means to be a logger, and the huge amount of investment that she and her family have made along the way to get there. And I don't think people, really realize that. A lot of you know that once you harvest it, you put it on a big truck, but we were really, interested in making sure that we had our sustainability story tied out, much like farm to table. People want to know where their wood's coming from. And so for our Seedlings to Solutions story, we wanted to make sure that we could track that. And so with our great partners at Georgia Pacific, we marked all our loads with a big, gigantic Jamestown J. And when it arrived on site at Georgia Pacific in Albany, they were willing to accommodate us and store all of our wood in a special pile that would then be run in one solid production run so that we knew where this wood was coming from exactly. We knew that it was coming from a sustainably managed forest under SFI certification. And all of these things become really important to our story as we're trying to explain how a farm to table type concept works in the wood industry. And I think that's a great place to bring it back to you, Russell, as you got us to lumber the last time. I got you to lumber now through the forest, and you can take the rest.
Thank you, Troy. So, because of the success of the residential construction market, and especially North American sawmilling practices and forestry practices, the industry is really focused on the production of dimension lumber, right? Sawmills produce dimension lumber. American forests are grown and harvested to produce dimension lumber, which are fairly small sticks of lumber. So the sourcing of heavy timber is rather difficult. So what we have available is dimension lumber. So how do we get from dimension lumber to mass timber? So that's where we're headed. Next slide, please. You can, of course, build large buildings with dimension lumber. So this is what we call a 5-story podium slab building. It's 2 stories of concrete, right? The bottom 2 stories are cast in place concrete, 5 stories of light dimension frame. But a building like this has significant limitations in span, the necessity for extensive fire protection, and so these buildings don't have a lot of flexibility. Right? Next slide, please. Fire is an obvious problem with any of the small sticks of wood that we use, whether it's a balloon frame or platform frame. Next slide, please. So it leads us to how do we get to mass timber? Because as a professor of architecture and structural engineer, we all yearn to make the business that we're in more sustainable. Many of us love wood and wood buildings. We love the nature of wood. We'd like to leave it exposed. Most of the wood buildings that you live in, if it's a platform frame building, has to be actually covered in drywall and other things to keep it fire resistant. We know that it's irresponsible to cut first growth forests and the big trees. The big trees need to be left alone to be enjoyed in other ways, not as wood buildings. But you can't build big buildings with little sticks of wood. Next slide. So here's where mass timber comes in. So mass timber is thinking about the wood stick, right? The dimension lumber, the 2x12, the sheet of plywood. Think about it scaled up 10 times, right? The dimension of lumber scaled by 10, wood members so big that they can span on a commercial scale and compete with reinforced concrete and structural steel. So instead of spanning 12 to 16 feet, if you're used to span tables for dimension lumber, we can span 30 feet, 45 feet, something like that. And so the elements are prefabricated in CNC shops and come to the job site ready to be installed. So these buildings install and erect incredibly quickly without a lot of on-site labor. Next slide. Mass timber comes in very many flavors, right? There's actually still quite a bit of innovation in the development of mass timber types. And I think, as Troy will tell you, mass timber is really coming to the United States from Europe and from Canada. So we're developing our own specific flavors and approaches to mass timber, which is fantastic and appropriate. But what you're primarily going to hear about is glulam, CLT, DLT, NLT, and I'll say some more about these in a second. These are all mass timber systems used for aggregating dimension lumber, usually, or sometimes wood strands or other wood fibers through adhesive or mechanical means to make very large members. Next slide. So these are mechanically laminated wood timbers. In the upper right-hand corner, this is nail laminated timber. In the upper left-hand corner is dowel laminated timber. In the bottom left-hand corner, this thing that says figure 7 is actually in my lab at Georgia Tech. These are some dowel laminated glue lams, right, with an FRP bumper ply. So these are examples of mechanically fastened mass timber. One of the advantage of mechanical fastening is higher fire resistance, for example. Next slide. I think what you probably mostly hear about is cross-laminated timber. It's kind of the most effective form of mass timber right now. And I think you can think about it as a sheet of plywood on steroids. So this piece of 5-ply CLT that you see hanging from this crane is 8 feet wide and 40 feet long. It has 5 veneers, if you will, but each veneer is a 2x6 or 2x8. So the total thickness of this sandwich is around 7.5 inches. And it can span probably around 25 feet. So this is an amazing piece of material. You can build a very large building very quickly by erecting these panels. Next slide. And if we go back to fire, one of the advantages of the early heavy timber buildings and our modern mass timber buildings is massive wood members don't support combustion very well. The char on the outside of these members is a natural form of insulation. And so as these buildings are subjected to fire, they tend to scorch and char on the outside and self-insulate. I guess I would challenge you to start your first fire this winter without any kindling. Just go ahead and light up your big oak log with just a match, and you'll remind yourself very quickly that you can't do it, right? You can't get something that's big lit without a whole lot of other smaller fuel to start with. So next slide. And I'll just leave it and turn it back to Troy and say, we've got a lot of innovation in the architecture and engineering space. on mass timber buildings. We're very excited. This is a building here on our campus at Georgia Tech. And we're very excited about Troy's work leading a kind of a commercial charge, if you will, to bring mass timber buildings to the Southeast. Troy?
Thanks, Russell. So it's me again. And I wanted to refresh everybody and reboot us with the conversation that we left off with, which is, we've got our forests, they're sustainable. We know that story and we tell it well. I think we should tell it all the time. And that leaves me excited as we transition from, the traditional things that we have been working with in the past and get into this mass timber construction and the impact that it might make. I get excited about it. And I think it's a fun story that we like to tell. When we started off and decided that we were going to build a mass timber building in downtown Atlanta, just like any developer, we went out for bid, put costs out, and my friends in construction development team, called me up and said, Troy, sorry, we're not going to be able to do it from U.S. grown or Georgia grown wood like you want to do. I know that sounds fun, but you know what? It's cheaper to do it from Austria or from Canada. And that was a little bit frustrating when, you're a Georgia timber owner and your company manages forests just right to the south of Atlanta, and how the supply chain works and you can't figure it out. But the reason why that exists right now is because if you look at the world of where these plants exist that are making the mass timber product, Europe is far ahead of us. They've been doing it. Their codes have been, out there longer. And so they've been building with mass timber for a lot longer than we have. And that demand has driven, mills being built specifically around the resource. And so you'll see a lot of mills coming out of Austria are very competitive. 70% of the capacity of mass timber plants right now currently is over in Europe. And if you look at the United States, we're just not there yet. We're growing in the business, but really we only have 18 plants. And so there is a future demand capacity that I think I get excited about. I think that if we build it, they will come. And I think we're seeing that in the industry. But right now, the reality is, if you're a developer and cost is what you're focused on, doing a farm to table seedlings to solutions building like we do is challenging in the United States because it's just not there yet. Where I left off was lumber, and that's where kind of Russell and I were left off. But the next stage is you get your lumber and you take it to a mass timber plant. And ours that we worked with was, luckily we knew we're, again, very close. One of soon to be the largest mass timber producing plant in the United States is they're doubling their capacity right now and should come online in the fall in Dothan, Alabama. So our supply chain is really tight. It's forests that are just south of Columbus, Georgia, trees being taken to Albany, Georgia for Georgia Pacific, and then right over the river to Dothan, Alabama to be made into mass timber. If you haven't seen it, again, our series, seedlingstosolutions.org, the videos kind of walk through how mass timber is produced and what that looks like, but you've got to tell people, explain how this material works. As Russell already said, there's two major components in a mass timber building that we have. We have glulam beams and columns. Those are the structural elements. Those are all kind of glued together in the same direction. And then there's the CLT panels, which are the floors and or the ceilings. And that's the plywood on steroids. One of the things, the benefits or the interesting things with mass timber is from a workforce standpoint, all of these pieces and parts, if you will, are basically, they're done off-site, they're done in a warehouse, and they come prefabricated and drilled. So the jobs are changing to being in one place, one location. That's kind of going to change the construction industry just in general. But now you've got people that are in controlled environments. We like this, and it's safety and the quality that's coming out of this, and the lack of waste when machines and computers are helping you make decisions is really interesting in the design is as well. Ultimately, what you wind up with is a gigantic kit of parts, and that kit of parts, gets basically pre-staged, out there, but it's like putting together a Lego kit. Or a piece of IKEA furniture. It comes with a big, Allen wrench, and you spin it and drive yourself crazy. But you got guys and people that know how to do this. But ultimately, you've got this gigantic kit of parts. It gets put on the back of a tractor trailer. that you can get just about anywhere. You deliver it into downtown Atlanta. This is, our building at Ponce City Market in downtown Atlanta, if you've ever been, but a very, very active adaptive reuse building that Jamestown did, with an amazing food hall, retail shopping, office, but a very big project, with over 3 million people that come to our site last year. That's the second most visited site in Atlanta next to the airport. That's an Uber statistic. But my point here is, if you've got an active campus and you've got lots of visitors, disruption in traffic is a big deal. And it's already a big deal in downtown Atlanta. So if you can bring your kit of parts in on a tractor trailer that just drops the truck and goes, that's a very big advantage to mass timber. And for our building, it only took about 50 truckloads to build this mass timber building that we're going to talk about and show you in a second. In comparison, we were building a building right next door, with a similar floor plate, and that building was taking 50 loads of cement a day. 50 loads a day compared to 50 for the whole project. When you're a developer and you're in a downtown urban environment, that's a big deal, because cement trucks that pump at cement sometimes break down, and that leaves you with 30 cement trucks parked out on Ponce de Leon Avenue. That's not good. So the mass timber goes up very quickly and very efficiently. You can see on these pictures that some of the little notches and carve outs that are in the pieces. So every piece has its place and fits into place very specifically. Sometimes there's fasteners put on them to put them on the floor plate. But at the end of the day, like I said, it's kind of all pieces and parts in a kit that just ultimately goes and gets lifted into place with a crane. So it's extremely efficient, as far as the construction process goes. And that leads to super happy, engineers who are, responsible for putting the building together. So our team at Jamestown is just thrilled to death, with this process. And while they're doing a concrete and steel building next door, all the things that we learned about the building was just really, really interesting. As it goes up, again, it goes up very quickly compared to other methodologies. And so here's just kind of a flash of time frame, and how it gets up, but you can kind of start seeing how it looks like a IKEA furniture kit. And you put in the glue, the beams and the columns, and then the floor plates come in, and then you stack and start going up. Very efficient. But by the time you get just past 100 days, 110 days, you've got a 4-story mixed use office building. And I point out here, in a very happy construction crew. And you can see here, if you do the head count, that there's only 8 people that it took to build this building. Usually there's only about 6 on site. And as comparison, the other building that we had next door with a similar floor plate has about 120 people on site. And so workforce becomes a big advantage to mass timber in the way that it goes. And it just takes, a smart crew that is focused on putting these pieces and parts together. And then they're off to the next project. We just really found that was very interesting from a safety perspective. Only having 6 to 8 people on site versus 120 next door with heavy things flying over your head. That was a big advantage that we think mass timber has. So here it is, kind of more complete. So you can say it's not a small building. It's a 4-story, about 117,000 square feet, retail on the bottom, an office on the top. We think it complements our building, Ponce City Market, which is a 1928 Sears and Roebuck, very well. And then here it is finished. We just opened the building to the public probably about a month ago, with Pottery Barn being the resident on the ground floor. We like the way that it turned out on the outside. It kind of looks, maybe it doesn't look or stand out as a normal building, but when you're inside and you walk into the building, one of the words we use is biophilic design, people drawn to nature, wood and everything. But just the southern yellow pine mass timber really speaks to people when they come in here, and it screams wood. If you buy a building from Austria or Canada, which is not a problem at all, technically, but the whitewoods and the firs tend to not have the pronounced grain patterns. They don't have the knots and the character. And time again, when I have visitors come and look at this building, they're always just talking about how pretty it is and how immediately they can tell that that the southern yellow pine just resonates wood and experience. And time again, one of those things I didn't realize or expect, but the building smells good, and people just love to come into it and feel it. And that's we hear this over and over from our friends at Pottery Barn. So this is the Pottery Barn. It has a 25-foot ceiling, gorgeous again, but it speaks to the type of building that a company or corporation like Pottery Barn wants to be in and be, something special, something different. But sustainability was a huge driving factor for why Pottery Barn wanted to be located in this space. They understand the story that comes behind it. And of course, being a furniture manufacturer, sustainability and ties to wood was really important to them, but it really made a beautiful building. As we wrap up here, don't forget that we have Q&A session that we can go into. So if you have questions, please put those in the Q&A section. But one of the things, again, with 3 million visitors at Ponce, one of the things that we had a lot of fun with, and where Russell and I really got to know each other well, was that we did kind of a design study with Georgia Tech students and challenged them to come up with, this is called, we call it a pop-up or a display, or how do you tell a mass timber story and let people experience it and touch it and feel it? Because you can't bring everybody on site to the construction site during development, but if you got people asking, what is that? It's definitely different. People are noticing it's different. How do you let them figure it out themselves? And so the great students at Georgia Tech, this was the winning design. It's called the Taurus Arch. Taurus, if you're not an architect, is a fancy name for tire swing. And the whole point of this, and I think where the Georgia Tech students really got it right, was to understand mass timber. You do have to touch and feel it and see that it's not just a piece of 2x4. So you can touch the panels that you have in the arch, but the tire swing part of the component allows the experience to push it around a little bit and stand on it and shake it and move it around. And that was really a big, huge part of it, because if you try moving this thing around and you realize it's heavy, it's different, it's made of wood, but it doesn't feel like wood. And I think it gives confidence and trust in people. And then they can scan a QR code and go to seedlingstosolutions.org and watch our videos and learn more about it. And we just felt like this has been really kind of a fun best practice in our experience of trying to tell the story. And that's important. The other thing that's been really important in our journey is the support that we've had from many people. U.S. Forest Service has been great, but we're in Georgia, Atlanta, Georgia, and Senator Raphael Warnock and John Ossoff, both of our senators and our representatives also. But our senators have been instrumental in advocating for mass timber and have understood how important that is to the whole economy of Georgia. But they have really embraced how our mass timber building is a vehicle to tie rural Atlanta, Georgia, or rural Atlanta back to rural Georgia. And so they've embraced that. But Senator Warnock has been instrumental in a lot of things. But my point here on this is on that side of the shop, this is a really, really great lane to be in, because Senator Bozeman from Arkansas, Republican, is a huge advocate. Tommy Tuberville from Alabama. Tommy Tuberville and Raphael Warnock are not people that you would normally believe would be together on issues, but they are when it comes to mass timber for different reasons. But both the Republicans and the Democrats agree mass timber is something that's very interesting. And so I think from a political standpoint, bipartisan, this is just common sense. And so there's becoming a lot of support for this as we move forward. And as we wrap up, Russell, when we first started this, and he was coaching me up on mass timber, and I was growing in my understanding. What we do talk about on the development side is, biophilic design, and people like wood and they're going to love the experience and it makes people feel better. And so it's the environment that, young people want to be in. So this is going to drive people back to the office. What I did not expect was nature. nature and that how nature draws back to a mass timber building was really unexpected with our first bear sighting in downtown Atlanta in a long time. And that, really shocked and surprised us, but we're, very pleased to see that Smokey also loves mass timber. And again, our support with mass timber and the U.S. Forest Service has been great. All kidding aside on this one, if you want somebody to advocate for you, and you want somebody who's trusted, when Smokey Bear says, mass timber is cool and likes it, that's a guy that you want on your side as well. So with that, I think we are done, Russell. So I'm going to stop this and turn it back over to Lynn.
Well, thank you, both Russell and Troy, for excellent presentations. Before we take our audience questions, I'd like to start off with one. Can you both speak to the importance of building codes? Because at the local and state level that allow tall structures to be built with mass timber versus steel and concrete.
Yeah, I'll take a first crack at that, Lynn. This is Russell. I would say, the modern day building codes are sometimes called life safety codes. And so the reason that we actually have building codes is to protect the public. So if you think, it's unusual that we have to inspect buildings like our private residence. What does the government have? Why do they have any role in what we do on our own land? To protect the public. So building codes generally protect people from shoddy work. And so building codes evolve a lot around fire. So the advent of many modern building codes is to make sure that buildings are safe for fire. And so buildings built of wood, because wood is a combustible material, are fairly limited in size and scale and have to be treated in certain ways, such as fire retardant materials or sprinkling, and most of all by limiting their sizes. So what has happened in the last, say, 5 to 10 years in North America, both in the US and Canada, is as more fire testing is happening on mass timber, the building codes are being slowly relaxed to allow for larger and larger mass timber buildings. So you're seeing these in Minneapolis, right, and at UBC, very tall mass timber buildings being constructed according to new versions of the International Building Code.
Yeah, and I'll tap on to that, Russell, as the developer side of the equation, is that while the architectural codes allow for up to 18 stories of mass timber, your local state, city, county, that's where the real rub is, and that you've got to get your local jurisdictions comfortable with using mass timber. And to Russell's point, usually the fire department is the major challenge of that. And so we saw that in Atlanta and in Georgia, where local counties and jurisdictions were putting up restrictions because they were afraid of this, and we had to change views. And so you got to get people into your buildings and become advocate. And people ask us, we built a 21-story building right next to this one. Atlanta at the time was not ready for an 18-story what is possible type building, so we did our 4-story. And as we got more and more people into our building and talking about it, there is another developer who's announced a tall building in Buckhead that's going to be built here in the next few years. And I also want to highlight on that same concept that going back to U.S. support with our legislators, there's lots of new initiatives and procurement policies from the United States in an effort to use this wood and use it as a preferred source. So you've got a lot of legislation moving that way. The Department of Defense loves this product. It's very resilient. And then if you think about some of those other things, I think it's also important, equally as important as concept is, if you look to lead to other countries, the resiliency of this product, for example, for earthquakes, is really interesting. And one of my favorites is that there's a gigantic shake table, and you can Google this if you want to do, earthquake shake table and mass timber. And these guys basically out in San Jose, California, have the world's largest shake table. This thing moves and gyrates and does all kinds of crazy stuff. Their whole job is to destroy stuff and build stuff and destroy it and see what happens. The 10-story mass timber building that they put up, they've dubbed the most boring test that they've ever did because they could not shake the building to death. And that's because, like, if you think about how trees bend and flex, different than concrete and steel, the properties are really interesting from that component. And so from resiliency, from hurricanes, and or earthquakes, countries like Japan are loving this product when they get worried about things. So I get really excited about, what this product does for the buildings of the future because, of all these things, but people are going to have to get over and get used to them before they show up in your neighborhood next door.
Thank you, Russell and Troy. I'm going to move to the audience questions. We have a few up here now. The first one is, beyond its uses in center cities, would mass timber have implications for suburban housing market? If so, what architectural forms, single family, townhouses, apartment houses are best suited to mass timber use?
Yeah, Mark, thank you for the question. I'll take it. I think that for the first part, a lot of times, if you imagine prefabricated housing, right? Any kind of prefabricated building could be built with mass timber, even though it's fairly small in scale. So the primary promise of mass timber right now is for a larger scale building. And what you're referring to are smaller buildings. But, the United States has a construction labor crisis. We don't really have the labor market for building buildings that we need in this country. And there are many people who are working on modularization of buildings, doing more of the construction in plants. So I think even mass timber will work its way down to the smaller buildings as more and more fabrication facilities like the Smart Land facility in Dothan come available. And there are some mass timber products that aren't so mass, if you will, mass plywood and others that aren't quite so massive, which might be appropriate for smaller scale buildings.
Yeah, and I'll put my developer hat on this again. As a developer, and we think about these things and look at things, multifamily, absolutely, Russell's right on track. Like, that is what most developers, or a lot of developers, are looking at right now and see the dynamics and where that is. And so I think to Russell's point again, where mass timber has this very, very unique lane is, things that repeat and can be built over and over become more and more efficient. And I looked at IKEA as that example. How in the world can IKEA deliver, a flat pack desk to me at the prices that it does? Yeah, I got to put it together, but there's real value there because they figured it out. And I think mass timber in that way, that if you're going to do multifamily housing or the next, the repeatability and the design and the way that it comes together as a kit could lead to huge efficiencies in how we house, people not only in the United States, but I get excited about how this product could be, for attainable housing, all over the world, and help, solve world's problems of putting safe and reliable buildings up quickly. I get excited about that land in mass timber as well.
Okay, great. Thank you, Troy and Russell. Next one is from Verna. What are the ages of trees typically used for mass timber?
Troy, you want to take that one?
Yep, I can take that one. So the real answer on that question is it doesn't really matter. You're using lumber, and lumber is graded out, and you need certain grades and certain qualities of lumber. And so there's not really necessarily an answer to that. But there is conceptually that older trees may have more higher quality. But in the case of our building, the forest that we harvested, we harvested about 100 acres of forest, which is very normal size for a final harvest. And that's what we used to build ours. And those trees were 26 years old. A loblolly pine, 26 years old. In the South, we grow them pretty fast. It can be used for lumber and lumber production, and that was fine. So, and then we've replanted that forest, and it's growing 50,000 trees right now as we've created the cycle over again. But the age really doesn't matter. I think it's just more, and that's really not how the supply chain works or disseminates. So, Russell, thoughts?
Well, and I have a follow-up question for you, Troy. What was
Yeah.
the DBH? What were the diameter of those trees when you harvested them?
Probably about a 16 or 18-inch tree.
Good.
Yeah.
All right, great. Our next question is from Scott. Fast-grown loblolly pine has a lot of juvenile wood and wide rings that reduce strength. Doesn't mass timber compensate for this significantly versus stick construction with weaker timbers?
Yeah, I'll jump in with this, Scott. I think your point is very well taken. If you think about the cross-laminated timber, it's a stack, right? It's a stack of wood that's adhered through the thickness. And when we bend wood, most of the structural members that we're talking about, cross-laminated timber or glulam, are in bending. If we put the best plies at the top and the bottom, let's say in ply number 1 and ply number 5, then we can use the juvenile wood plies in, let's say, plies 2, 3, and 4. So they do a lot of regrading of lumber at the mass timber plants and put the best plies on the surface, both for appearance reasons. And then you're exactly right. We get to use the juvenile wood, the lower grade wood in the stack in areas where it's carrying less stress.
Okay, great. So the next question is from Paul Sutter. Could you say more about the carbon sequestration benefits of mass timber construction, particularly as compared to concrete dominant structures?
Troy, why don't you start and then I'll jump in.
Sure. So I mean, we started off the whole part of this again is you know, if we can change the way and what we do with building materials, and so and we've learned a lot on this one, and we're really excited that 619 Ponce is actually is the first mass timber building that's been registered on a carbon registry that the state of Georgia has created for the specific concept of the benefits of using mass timber construction over concrete and steel. And so Russell and I were on a team of the top thinkers, I guess you would say, in the world. And thank goodness, Russell, you were there. And so math is hard for me. I'm a forester, but carbon math is even harder. And so there are great minds and great people that know and understand how to calculate carbon and how it gets sequestered and the life cycle that goes into that. But the bottom line analysis, as the forester in the room, is that when you compare our 619 Ponce building to a more traditional similar building that would have been used concrete and steel, we did all the math based on the way that the Georgia Carbon Registry is calculating that, and it's a 75% reduction in carbon emissions compared to concrete and steel for our building. And I think the overall consensus is that's probably going to be about right for most buildings. Our building benefited some with our local grown story. So through the whole life cycle, that helps as well. But that is indeed the benefit is, you know, you can build 4 of these buildings for every 1 concrete. I also like when you're talking about the carbon and what this 619 Ponce builds in the state of Georgia, the 619 Ponce building would have been grown in 16 minutes. So we're growing a lot of forest in Georgia. We're sequestering a lot of carbon, and all of a sudden you got this carbon, you know, vault, if you will, at 619. All those things lead into great stories for carbon. And Russell, you're the brain on this if you want to talk about all the other awesome things.
No, I think you covered it very well. There's a follow-on question, we can address it, but I think you did great, Troy.
Okay.
Thank you. We'll move on now to Charles. What have been Europe's biggest types of projects?
Well, Charles, from an architectural educator, I think we have a lot of work to do, and especially in the southeastern United States. And if you travel much in the Pacific Northwest, you would know that the architecture of the Pacific Northwest has a lot more fluency with timber design than we do in the South. And that's changing, but I would say Europe is a lot more like the Pacific Northwest. There are a lot of varied structures out of mass timber in Europe. Even big box stores like a Home Depot can be mass timber in a place like Europe. A lot of small housing. So they have a lot more of the CNC plants that do the final manufacturing of the mass timber, cutting all the joints. And so that's really a barrier to what we can do with mass timber right now. We don't just need the plants that laminate the mass timber. We need many more of the CNC plants that produce the final panels themselves to the right dimensions to erect more complex building types. So right now, the rectilinear panels that you see in Troy's building are very easily produced here in the Southeastern United States, but we've got more work to do to produce, let's say, a wider range of buildings like they do in Europe and the Pacific Northwest in mass timber.
Yeah, Russell, I'd love to get your thoughts on this comment, but I think one thing that question highlights is, one size doesn't fit all. Going tall is sexy, I would love to do a project that's 18 stories tall and be involved with that. But I tend to think, Russell, that mass timber construction is ideal for what we've done, the 4 to 6 story kind of repeatable box without high-end architecture. Like that's kind of where I think its lane is, or warehouse, like you just pointed out. I think I'll also point out hybrid construction is really interesting in that, I would love it for all to be timber, but it doesn't have to be. So you can combine steel and concrete beams with the CLT flooring, and that's very efficient. And one of the ways that we get into it, and I think Europe's embraced that. We've got a building in DC where this downtown DC environment, and with height codes changing, they stacked 3 stories of mass timber on top of an existing building because it was lighter. There's one of those going on in Atlanta. But I think the bread and butter to me, Russell, love your thoughts because you see them, but I think the lane is not tall, maybe for it, is in my view.
Yeah, I agree. Schools, I mean, there are many building types which could be suited to mass timber. It just takes architectural imagination, dealing with building code officials for the first time or the second time, and then design talent. Yeah.
Right. Thanks for that. Next is John. How did the wood building cost out compared to the concrete next door?
I think that's probably for me.
Yeah.
But Russell, if you have thoughts, because I get this one a lot, and so I can answer generically, and Russell's probably got the most, pulse on actually where markets are right now. As the 619 Ponce building penciled out, and the generic answer to this question is, it seems like, a mass timber building right now today will cost you about 15% more than doing traditional concrete and steel construction. And I think that's probably true. And I want to point out that that's only for the components that, like with the building behind that you're looking at. That doesn't include all the other stuff for the building. That's just the beams and the columns and the floor plate might be about 15% more. We, with our homegrown solution and transportation costs and other factors involved, it was not 15%. We're not ready to release that number, but we will be soon. But it wasn't 15%, it was less than that. And I think as the industry evolves, we've run into really big challenges, like with insurance. If you think about our building with only 6 to 8 people working on it, and the tractor trailer truck just simply parks the trailer right next to the building, and it picks up the pieces, and there's no flyover zone time, and everybody's expecting wood to be flying, and all of that, like the safety factors alone should be significantly lower, but nobody knows how to price out an insurance on a work site building mass timber right now. And so you get charged more. The building's that way as well, but as people grow and learn, we figure these things out. But I think we will get into a point where it is very cost competitive, especially with hybrid type models. But right now it is more expensive, and I think you can predict and plan that it would be. Russell, what are your current state of the art thoughts on that? You know that industry more than I do currently.
Yeah, I think that it's a capacity issue in the South. The problem is that we don't have enough manufacturing, so we don't really know what the floor is in terms of cost on structural only mass timber. So, we might think that, let's say it costs around $45 a square foot to build a reinforced concrete structure. I'm not talking about a building. I'm just talking about the reinforced concrete frame itself, right? the building itself probably costs, I don't know, $450 a square foot, but just the structural frame. So it seems like, Troy, you're right on if you say, well, it's a 15% premium, but I think it's a premium because a lot of our mass timber plants have 2-year backlogs of production. So people are so excited about this technology. We have this kind of conundrum. That's going to require certain people to make capital investments on these kind of plants, throughout the Southeast and throughout the United States. And so we won't really understand where we're going to get in terms of cost parity until there's more mass timber production.
And I know we're getting short on time, but let me follow up with one more comment on that. Is that the other side of this equation is greedy developer. Put that hat back on. You're not really going to do anything for the good of the world. Like, you're actually looking to build a building to house people and attain leases and rent, right? So that's why we do it. And if that doesn't pencil out, then it's not going to work. But I think over and over again, what I hear from our building and in other buildings, that there is a lease premium to these buildings. And some people underwrite. We didn't really underwrite it, but we demonstrated it. We've got the top 3 floors are office, and this is not a good time to be leasing brand new office space. But we're thrilled that we did, and the lease rates held up as comparison to Pont City Market right next door to us, and Pottery Barn's on the ground floor. And so people are willing to pay a premium to market for commodity like office product or other products. And so while it may cost more, we tend to think that just because of this is the kind of building people want to be in, that gives us an advantage and perhaps a lease advantage.
Okay, I'd like to just have you field one more question, and I'd like to get to this one from one of our attendees. Please, I did not get how mass timber can help in carbon sequestration. We only have a few minutes left, but I think we need to make sure that we bring that point home. It's a great question.
Sure. So let me just say, we know that the production of steel and concrete produces carbon, right? Carbon is released into the atmosphere in steel mills, and cement kilns produce dramatic amounts of carbon. Trees sequester carbon when they grow. They soak up carbon from the atmosphere. It's the carbon cycle. And what we know about these commercial buildings is that once the tree is full of carbon and we use that carbon minimally processed in a mass timber building, that carbon is not being released to the atmosphere. It's sequestered. We call it biogenic carbon, and it's locked into the building for the lifespan of that building. So I think that's the net positive aspect of a mass timber building, is that the life cycle of the tree soaks up carbon from the atmosphere. We don't have to add a lot of carbon to process that tree into mass timber buildings, much less than we would to make cement or steel and then construct a concrete or a steel building. And then the life of that building, during the life of the building, the carbon locked into the wood, the biogenic carbon, is not released, it's sequestered. So that's the net positive benefit. If you were to compare, say, 619 Ponce to an equivalent, say, cast in place concrete building, which would be the kind of standard replacement for that building, absent Troy and his team.
And I think that really highlights the whole point of forest optimism here, and probably some of this audience and where the lane that we normally play in, and where I really get excited about where we are today and about this mass timber story connecting. As people understand this story, our sustainable forest management story and forest health story becomes huge to this, because as I highlighted, we've got 50,000 trees replanted and starting the cycle over, and they're growing healthy, they're growing fast, and they're sequestering more carbon today. And then the building gets locked up and protected and stored in the building in 619 Ponce. All of that is a story that people are understanding and getting excited about, and honestly making foresters in this industry kind of the cool kids in the room. And I talk to all these really interesting architecture design conferences, environmental type conferences about this, and people are really getting excited about substituting and changing the way the built environment works. And that's the big part of it, I think, is that this is a solution, and this is an impact solution that really makes forests and forest management relevant today. I get excited about that as a forester.
Okay, so I would just like to make sure we get to the very final question. If you could just do it as briefly as possible, but do termites present a problem with mass timber buildings?
No.
No.
Okay, great. I know that there's a natural defense, but I just wanted to make sure. So I wanted to say thanks to everybody for attending.